Section 23.11, the stork reaction. Gilbert Stork at Columbia University, he's still around up there, I think, as a professor emeritus. He found a reaction that solved a number of problems in aldol and this type of chemistry. What he found, if we look at the general reaction, is that the use of an enamine, and I'm going to illustrate this with the pyrrolidine because that's the most commonly used amine, being cyclic, pulls those CH2 groups back a little bit, makes the enamine formation. We've already covered enamine formation, so I'm not going to deal with that. He found that these would react with particularly aldehydes and ketones to the better electrophiles to produce the Michael type addition to these. So there's the carbons 1, 2, 3, 1, 2, 3. Then we'll add, here's the bond to the new bond that goes to what was the enamine, and we see the formation of an aminium ion. Now, why does this occur? We'll talk about it in a minute. But we're not done with this reaction because then there is an aqueous acidic workup. And again, we've already done this part. This is imine or iminium ion hydrolysis. We'll go to there are the carbons 1, 2, 3. There's our new bond. And there's the pyrrolidinium ion that, of course, can be precipitated out and recovered. And so we see this produce a 1,5-diketone. 1,5-diketone. So why does this reaction occur the way it does? Before I give you a specific example, well, let's go ahead and look at a specific example. So a useful one is the enamine made from cyclohexanone. We can react that with ketone, and then upon aqueous workup, we get a product. Ketone, 1, 2, 3. There's the phenyl group. And again, 1, 2, 3, 4, 5. So 1,5-diketones. So let's take the cyclohexanone here and look at why this reaction occurs. We saw this a little bit already in enamines. There's a resonance form where we can bring that lone pair down. Push that pi bond over here to the alpha carbon. So in this particular resonance form, we're going to have charge separation, seeing an aminium ion, but then over here, we have a negative charge. So what this means is that this compound is very nucleophilic at the alpha carbon, and so the mechanism of this is like Michael addition, that alpha carbon attacks there. You swing up, then that produces conjugate addition product, and then of course with aqueous acid we can work that up. So that's just the basic features of this, the new parts. I'm not going to do the hydrolysis and things. We've covered all those before.